Polars. A blazingly fast DataFrame library. Pandas is no doubt a very popular library for working with data frames. We cannot think of data science projects without pandas. Then why do we need any other library such as Polars for data frames? Although pandas is a very powerful data frame library, it is not efficient for big data. Polars aims to improve on pandas' lack of speed and efficiency for large datasets. Let's quickly discuss about the important features of Polars. Polars uses Apache arrow arrays, which are more efficient than NumPy arrays used by pandas. Queries are processed in vectorized manners. Polars is blazingly fast. It is written from scratch in Rust, designed close to the machine and without external dependencies. Another important feature is parallel processing. Polars utilizes the power of your computer by dividing the workload among the available CPU cores without any additional configuration. Polars provides first-class support for all common data storage layers such as local, cloud storage and databases. Out-of-core processing. The streaming API allows you to process your results without requiring all your data to be in memory at the same time. Polars uses vectorized query engine. Using Apache Arrow, a columnar data format, to process your queries in a vectorized manner and SIMD or single instruction multiple data, to optimize CPU usage. So, if we want to work with large dataset, then we may consider Polars for handling data frames. This was a very brief introduction. Now let's learn the basics of Polars in Python. If Polars is not available in your system, then you may install it using the pip command. Let's confirm whether Polars is available in our system or not. As we can see, Polars version 0.20.7 is available in our system. Although in real-life applications we import data from various sources such as databases, large files in various formats such as CSV, JSON, Parquet, etc., we will start our Polars journey with a handmade data frame as shown on the screen. Our data frame has 3 columns, roll_no, name, and marks. Let's display the data frame. Run the code and check the result. And this is the output. Isn't it very similar to pandas? We may save our data frame for future use. Let's save the data frame df as a CSV file, result.csv. And here is our CSV file, saved in the working folder. We may also mention the complete path. Let's view the contents of the file. Yes, this was the content of the data frame df. That is, the data is saved perfectly. Now we will create a data frame from a CSV file. Here we will use the result.csv file created in our previous example. Write_CSV is used for writing to a CSV file, and read_CSV is used for reading from a CSV file. Here we have loaded the data from result.csv to a data frame object df. Let's display it. Perfect. We had created this data frame by typing in our previous example, but here it is from a CSV file. How convenient it is. Like pandas, we may check the shape of the data frame using the shape attribute. We may use the columns attribute for showing the column names of the data frame. Selecting columns. Wildcard character asterisk for selecting all the columns. Selecting only marks column. Selecting name and marks columns. Now let's see how we can filter rows that meet some condition. Here's our CSV file that is used for creating the data frame. Let's check the column names of our DataFrame DF. Sorry, we need to use the print function for displaying the result as we are running a script file. And here are the column names. This is in accordance with the CSV file. Let's display the first few rows. Now let's use the filter function for displaying only the rows where the class is 8. Look, the rows are for class 8 only. We may write more complex queries with filter function with more than one condition. Here are a few more examples. Ampersand is used as an AND operator. Here we have mentioned two conditions: the class must be 8 and the section must be a. Uses of in_between for selecting a range of values. Is_nan may be used for selecting rows with nan values. Nan stands for not a number. Here, in our data frame, there are no such rows. Is_not_nan is just the opposite. Rows with null values may be selected using is_null. Now we will learn how to add new columns to an existing polars data frame. So, let's first create a new data frame from scratch. Here the data frame DF stores IDs and names of 5 students. Let's display it. Here we will use the with_columns method for adding new columns to the data frame DF. In this example, X is a polar series that will be added with the data frame DF using the with_columns method. See, a new column X is added to the data frame DF. We may rewrite the expression using column alias as shown here. We may use the polars.lit function for inserting literals as column values. Now let's do some meaningful things. Let's insert a new column that stores the marks obtained in math. Now let's insert 2 more columns for chemistry and physics in one go. Now let's change the expressions using alias. The expressions can be passed as a list also. Now let's insert another column that holds the total marks obtained in math, physics, and chemistry. Let me complete this lesson here. We will learn more about polars data frames in our next lessons. If you find this lesson helpful, please don't forget to like, share, comment, and subscribe. Your valuable feedback is important for me and will help me improve the contents of the channel. Thanks for watching up to the end. Hope to see you in the next. Bye.